All right, we're moving on to part three of lesson three. It's called breaking apart figures to find volume. These are rectangular prisms that have basically been like almost like they're glued together. And we have to find the volume of each part that's been glued together. And I've got some examples here to kind of show you what I mean. If you're in class, I would have given you some unit cubes to build a composite rectangular prism. And just to get right to it, this is what we're talking about. So you've got like one, you've got one right here, and then you got a separate one right here on top that kind of sits right on top of it like that. So that's again composite when you're combining two different things. So composite, combining, think of it that way. Here's another example of a composite, and here's another one. And the point of today's lesson is to figure out how you can do the volume of this whole thing. Like this entire object here has a volume, but it's not so easy to figure out with a formula like we've been doing with the previous examples. This is where we're going to have to break it down into two parts and do it that way. So notes are starting on page 43. And right away we see this composite figure right here, except for this one, it doesn't have like all the unit blocks put together. So instead of being able to count blocks and find it easily that way, we're going to have to kind of basically slice this and then figure out what each slice is, what each slice has. So my suggestion is to do it like this, to turn it into a left and a right side. And we're gonna split our notes into left and right. So here's left and here's right. And up here above the picture, I'm just gonna put left and right. I know you know you're right from left, but this does help us make a better connection. So both of these are going to use the formula volume equals length times width times height. So for each side, let's go ahead and start with that. It's a great habit to get into for when you work on higher levels of math and science. So let's talk about the left. So we've got, it's 6 feet here. It's 2 feet tall. We've got to figure out what the heck this side is. We need to figure that one out. And that's one's kind of tough unless you look at the rest of the figure. I'm going to use a different color here to kind of help point this out. So this whole side on the left is a combination of this 4 feet and this 6 feet, if you can picture that. So this is going to be 4 plus 6, and that will give us a measurement of 10. So down here, we're just going to plug in our numbers, 2 times 6 times 10. And then that's going to give us 60 times 2. And it gives us a total of 120. 120 cubic feet. And it's important that we do that for each side. Okay. Now let's look at the right side. I'm going to get rid of these just so they're not confusing. The right side, we've got 6 feet. And we've got 6 feet here. But we don't know how tall this is. Although if we look at the whole figure, we know it's probably the same height from left side to right side. So over here, it tells us already it's 2 feet tall. So we could do 2 feet right there. This is going to be 6 times 6 times 2. And that's going to give me 36 times 2. And that's going to give me 72 cubic feet. All right. We're not done though, because there is a last step to find the total volume of this whole figure. And for total volume, you have to add up what we have here. So we're going to have 120 cubic feet plus 72 cubic feet. And that's going to give us 192 cubic feet altogether. So you got to break it apart, figure out the two different parts, and then recombine your answers to get your final answer. So that's 192 cubic feet. It's not so bad if you take your time. Just see what clues are already there for you. All right. So it talks about a couple different ways to break it apart. We did it a left-hand side and right-hand side. This shows that you can do a top part and a bottom part. Here's the way that we did it. And go right into the notes here. So look at the first model. That's the one where it's a top and a bottom. How can you find the volume of each rectangular prism? Well, we already did that with our first example. So we're just going to write, this is what we could have used for that one. For number 2, how can you find the volume of the entire garden bed? And we did that as the last step, add up the volumes of both prisms. And what is the volume of the entire garden bed? Show your work. We actually did on the previous page. So all we have to do is write in our answer from the previous page. Or from the first page, excuse me. Now look at the second model. That's one where we did that method. Show how to use these expressions to find the volume of the garden bed if you break it apart this way. When you evaluate an expression, do the operations in the parentheses first. Now, we have not gone over and reviewed the order of operations, but what they're basically asking is this. So our left-hand side was 10 times 6 times 2, and we put all those in the parentheses. And in the right-hand side, we do 6 times 6 times 2. And then we took those totals and added them together. So we could have done this all in one step, but I broke it out into a left-hand side and right-hand side. And this became 120 plus 72, and that equaled 192 cubic feet. So again, one of the most basic things to remember for order operations is do what's in the parentheses first and then figure out the rest later. Some students are already doing this in their MyPath lessons, I've noticed, and this is some good review for that. Do you need to break apart a solid figure in a certain way to find its volume? No, you do not. You can break it up any way that you'd like and still get the same answer. You just have to remember, just keep track of how many parts you broke it up into and add all the parts up together at the end. You can skip 6, just cross that out. And let's do a couple questions on the back. The Recreation Center has an L-shaped pool. One part of the pool is 8 meters by 6 meters. The other part's 12 meters by 6 meters. The whole pool is 4 meters deep. So just picture like a regular pool you've been swimming in, and if it's in the shape of an L. So one side is this and the other side is this. But let's just break it down since we have all the numbers. Split your workspace in half. And we will do, for this one, we're going to go back to doing base times height, because I want you to get some practice with both of these different methods. All right, so one part of the pool is 8 meters by 6 meters. So we know the base for that one is going to be 48, because 8 times 6 is 48. We know the entire pool, its height, or how deep it is 4, so that sets up that side. For this one, we have 12 meters by 6 meters, so that's going to be our base. And we know 12 times 6 is 72. And the height for that one is the same, it's the 4, so we have that. For this, I'm just going to give you the answer for it. 48 times 4 is 192. And these are cubic meters. I know that 72 times 4 is 288 cubic meters. And we're not quite done yet. What we have to do is add 192 plus 288, and that will give us a total of 480 cubic meters. If you were in class, we probably would have broken down the math a little more, but for the sake of time, we'll just keep it short. Next question, number 8. What is the volume of the solid figure below? Show your work. I could do this one of two ways. I could do this. I could do it into a top and a bottom, or as I'm going to do for this one, I'm going to turn it into a left and a right. So let's break up this workspace into a left and a right space. And we're going to go with the classic length times width times height, and length times width times height again for this one. All right, so left, we got our numbers here. So I know it's 30. I know I've got a 10 here. It's 10, 1. We just need to know this measurement right here. And if we look down over here, that 30 is going to be our measurement for that. And these all multiplied together give us 9,000. Over here, let's use a different color, just so these stand out a little better. So I've got 20 and 30. But I need to know this measurement right here. I need to know this one right here. Now, the grand total of this is 30 centimeters. This piece right here, that is 10. So if you take 10 away from 30, we know that that's going to be 20. So 20 times 30 times 20 is going to give us 12,000. Okay, and then to get our final answer, we have to add 9,000 plus 12,000 equals 21,000. And these are centimeters, so they're cubic centimeters. And last question. What's the volume of the solid figure below? Show your work. Now this one I want to do a little different. We'll do a top and a bottom. Or upper lower. In fact, let's call it upper lower instead. That's a little more. So the upper part and then the lower part. All right, our upper part here. I get to choose either way, and I'm just going to go with a simple length times width times height for both. All right, so upper part. We've got a 4. I've got a 4 right here. I've got a 2 right there. And we just need to find out what this side is. But if we look over here, it tells us that that's 3. And this gives me a total of 24 cubic feet. I'll switch colors. We'll do the lower part here. We've got an 8. We've got a 3. And we just have to figure out how tall this is, this right here. Since this whole thing is 6 feet tall, and we know this section is 4 feet, we know this one is going to be 2 feet right there. So for this one, you've got 2 times 3 times 8, and that gives me 48 cubic feet. And again, the last step is combining 24 cubic feet plus 48 cubic feet gives me a grand total of 72 cubic feet. So that's it for our question here. What we're going to do is just go over our homework for what we have, the homework assignment. And that's going to be your reflex math. And do your reflex math until you get a green light. Let's go to this. And that should do it for today.